All right, so here we go. I'm working on this review sheet here, and I'm going to work out the answers. So when somebody tells you that the cotangent of negative theta is equal to -2, so using our identity here, cotangent is going to be an odd, cotangent is odd, so that means that the left side is opposite the right side. So that means then that if the cotangent of negative theta equals -2, then the cotangent of regular theta equals +2. All right, so that also means that the tangent is 1/2. So if I want to find the other things, actually I want to find the sine, right? So I could use my identity that I could find the cosecant, which would find me the sine, so I guess I didn't really need the tangent, so I'd use this one. So cotangent squared, so if I get 4 plus 1 equals cosecant squared, so I'm putting cotangent squared plus 1 equals cosecant squared, so 5 equals cosecant squared, so it means that the cosecant is equal to the square root of 5 plus or minus, and so we have to pick which quadrant we're in. So the cosine is less than 0, it says, so it means we're not here or here, and we know that the cotangent is positive, so the tangent's positive, so we are here. All right, so if I'm looking for the sine is the reciprocal of the cosecant, so it's 1 over radical 5, and in this quadrant it is negative. So if you rationalize that, you'll get radical 5 over 5 negative. All right, so for number 2, verify this identity. So on the left side, I notice that there's a cosecant squared I can take out, which leaves me with secant minus 1. All right, equals secant and 1 plus cosine. Okay, let's see. Well, so I factored the left side, which didn't really do me a lot of good. I think I'm going to work on the right side. Multiply by the conjugate. So the conjugate produces 1 minus cosine squared, and 1 minus cosine squared for these two is sine squared. I got secant on top and 1 minus cosine. All right, so let's go ahead and multiply this top part out. So I got secant times 1, and secant times cosine, they're reciprocals of each other, so that makes 1. So see, I'm getting that part right there, and then sine squared. Well, if I bring a sine squared up next to this guy, it becomes a cosecant squared, and that is the same. All right, and again, there's many ways to do that. So 3, verify this identity. So we have ln of cotangent plus ln of 1 plus cotangent squared. Oops, that's mine, equals ln of cosecant secant. Okay, so let's see what we got here. 1 plus cotangent squared is equal to cosecant squared. So cosecant squared. So I think I'm going to multiply these together. So I have ln of cotangent times cosecant squared. Well, cotangent is cosine over sine. Cosecant squared is 1 over sine squared. So I guess we'll just have to rearrange those. Here is cosecant is 1 over sine. Secant is 1 over cosine. All right, what's going on here? Cosecant squared, multiply, cosine over sine. All right. Cotangent. Oh, I wrote this wrong. 1 plus tangent squared. I knew something was funny. This is 1 plus tangent squared, which is something also, but it's secant squared. There we go. All right, so secant squared is 1 over cosine squared. There we go, cosine squared. All right, so now this cancels out with that, and I have a match. I have ln 1 over sine is cosecant, and 1 over cosine is secant. There we go. All right, phew. All right, number 4. So in number 4, I'm going to work on, let's see, I got sine 2x over 1 plus cosine 2x equals to tangent. All right, so sine 2x, definitely replaceable with 2 sine cosine. 1 plus cosine 2x. Well, cosine 2x, I think what I will do is replace it with 2 cosine squared minus 1, because I have a 1 in front, and so 1 plus 2 cosine squared minus 1, and look at my 1's go away. So now I have 2 sine, cosine on top. The bottom is 2 cosine squared, and my 2's cancel. One of my cosines goes away. Sine over cosine is tangent. All right, moving along, number 5. Number 5, on top it has cosine y minus sine y. So that cosine y minus sine y on my numerator, I'm going to expand that into cosine x minus y. Cosine x, cosine y. It's a minus, so it'll turn to a plus sine x and sine y. This is all over sine x and cosine y. All right, so I'm going to make 2 fractions out of this. I'm going to make a fraction with this numerator and denominator plus this one and this one. All right, so when I go ahead and put this piece over that piece, notice my cosine y's cancel, and then I'm left with cosine x over sine x. Plus, when I put this item over that item, the sine x's cancel, and I get sine y over cosine y. Well, this is cotangent x, and this is tangent y, and we're done. All right, number 6. We got cosine squared equals cosine 2 theta plus 1 over 2. All right, well, cosine 2 theta, I think we will replace that. And I want a cosine, so I'm going to go ahead and use this guy right here, 2 cosine squared minus 1. So I'm going to replace this with 2 cosine squared minus 1, and then I have a plus 1. The 1's cancel, then I have this, so my 2's cancel, and we got it. All right, number 7. So solving. So I got 2 minus sine squared equals 2 cosine squared of x over 2. All right, so this guy right here, that's like saying 2 cosine of x over 2 squared. That's the same thing. So that cosine of x over 2, that half angle formula right there, is right there. So I'm going to put it inside the parentheses, and we're going to square it, so this whole radical is going to disappear. So when I put that inside, plus or minus, and then inside here is 1 plus cosine over 2, and I square it, well, this knocks out. And then when that's gone, then the 2's can cancel as well. So I have 1 plus cosine left. 2 minus sine squared. All right, so sine squared, let's change that to 1 minus cosine squared, because I got a cosine over here. All right, so 2 minus 1 is 1, and a minus minus produces a plus cosine. All right, so what I did right there is 2 minus 1, minus minus makes plus, and these went away. All right, so the 1's go away, so I got cosine squared. I'm going to bring the cosine over. So factor out a cosine. So cosine is equal to 0, and cosine is equal to 1. So that means I got, what? Cosine is 0 at pi over 2 and 3 pi over 2. Cosine is 1 at 0. And so all of these, I would say plus 2 pi n. Or you can also combine some of them and say plus pi n, but this is fine. All right, number 8. So on number 8, we have all solutions. Now I guess I should have said on number 7 all or some, but I guess I was just assuming all. So on number 8, I got 4 sine squared 2x minus 3 equals 0. So I do have a formula, so I could read this as 4 sine 2x squared minus 3. So I could do that, but replacing sine 2x with its replacement of 2 sine cosine doesn't really help me. It would make this worse. And so I think I prefer to do this. Let's move the 3 and divide by 4. So let's get sine squared 2x equals 3/4. Do the square root. So sine 2x equals radical 3 over 2 plus or minus, and just deal with it that way. Because remember, I want to take 2x and set it equal to any of the answers. So 2x, one is sine radical 3 over 2. I'm going to have 4 answers because it's plus or minus. And we're all going to be plus 2 pi n. All right, so 8. Let's see. Radical 3 over 2, so it's pi over 3. 2 pi over 3, 4 pi over 3, and 5 pi over 3. We are dividing these all by 2, so my answer turns into pi over 6 plus pi n. This turns into 2 pi over 6, so that turns into pi over 3 plus pi n. This turns into 4 pi over 6, which is 2 pi over 3 plus pi n. And the last one, 5 pi over 3, so 5 pi over 6 plus pi n. So I have to test these to see which ones are going to give me solid answers between 0 and 2 pi. So frankly, pi over 6, I'm going to start with there. So if I take pi over 6 and I add 180 degrees to it, so pi over 6 plus 1, so I'm doing pi over 6 plus pi right now. So that would be 1/6 plus 6/6, so it would be 7/6. Okay, so that's not on there, so yeah. So if I'm already at 7 over 6, which is right here, if I add 180, that'll be past where I want, so I'm not going to do any more. So pi over 3, okay, good. If I take pi over 3 and add pi to it, so that's adding like 1/3 and 1, so that's 4/3. So that's valid, 4 pi over 3. If I'm already at 4 pi over 3, which is down here, if I add 180 to that, it would be past what I want, so that's done. So 2 pi over 3 plus pi n, so plus pi. So 2/3 plus 3/3 would be 5/3. And if I add another, that's too big. Then 5 pi over 6. And also, oh, I forgot to list 2 pi over 3 here. Hang on a second. So, no, well, wherever. It doesn't matter where I put it. I guess I was going to put it right here. All right, so then 5 pi over 6 plus pi would be 11 pi over 6. All right, so 1, 2, 3, 4, 5, 6, 7, 8 answers. So those would be all the x-intercepts of this graph right here. All right, phew. So number 9. So looking at number 9, this is just a nice factoring problem. It looks like this problem, 3x squared minus 5x plus 2. Nice simple little factoring. All right, maybe you like to do your factoring like this. 3 times 2 is 6, put a -5. So I'm going to need -3 and -2 to multiply to 6 and to add up to -5. So that means I'm going to have x minus 3 and x minus 2. Divide those by the 3 that we multiplied. So it's x minus 1 and 3x minus 2. All right, so 3, these were all cosines. That's 2, and then cosine minus 1. Okay, so there we go. So here we go, cosine is equal to 2/3, and here cosine is equal to 1. Well, cosine equal to 1, I recognize that happens at 0. So one of my answers is 0. This one I do not recognize, but cosine is positive in these two quadrants, so I'm going to find the answer for that in those two quadrants. So I'm going to grab my calculator and go ahead and see when the cosine is 2/3. So I have to do inverse cosine of 2/3. So here we go. Make sure I'm going to put myself in radians. Well, actually, let me do degrees first, and then I'll show you in radians. So I will do second cosine of 2/3. So that's 48 degrees, we'll say. All right, so what we found is that there's a 48-degree angle right here where this is true, and then I also need a 48-degree angle down here. Well, 48 degrees down there is basically 360 minus 48, because it's everything but 48. So 360 minus 48. So like 312. All right, so I want those, and I want them in radians. So in radians, for the first answer, for this 48 degrees, I would just go ahead and do the same thing that I did earlier, but I would make sure my calculator is in radians. All right, so 0.841. And then my other answer is everything but that. So it's like it was 360 minus 48. So instead of 360, we're using 2 pi minus that amount. So 2 pi minus that amount right there. So 5.44. So there's my 3 answers. All right, number 10. So number 10 says 2 sine x equals tangent x. All right, well, I'm not too sure what to do here, but I do know tangent is sine over cosine. So maybe I fix that, and look at that. Let's cross multiply there. So I get 2 sine x times cosine x equals sine. All right, and I'm going to pull this over. So 2 sine x cosine x minus sine x, and I'm going to factor. So take out a sine, leaves me 2 cosine x minus 1. So sine is 0. And here cosine is 1/2. Okay. All right. Now I did have a fraction earlier. Cosine can't be 0, but I'm not saying that it is. So here we go. When is a sine 0? The sine is 0 at pi over no. At 0 and pi. Cosine is 1/2 here and here. So it is at pi over 3 and 5 pi over 3. And all of these, it just said solve, so I should say for all of these I would say plus 2 pi n. Or you could put these together and say plus pi n. All right, number 11. All right, so find all the values of theta in this interval, so from 0 to pi, where this equation is true. Cosine 2 theta equals negative sine squared theta. Okay, so cosine 2 theta. So that I need a replacement for. So, and because that's on the other side, I think I will pick finally a different replacement other than this one. I'll pick this one. So 1 minus 2 sine squared equals negative sine squared. So I'm going to put that over there. So 1 equals, if I add 2 to a negative 1, I get 1. And do my square root. So I added 2 to negative 1 right here. All right, and then so look, sine is equal to plus or minus 1. Well, that happens here and here. But my restrictions were in this area. So the only place that this happens in this area from here to here is right there. So the only answer I will give is pi over 2. All right, and number 12. Simplify this expression. negative 1 plus cosine, 2 cosine squared of 67.5 degrees. No calculator. All right, so this right here, 67.5. If you have 67.5 times 2, let's see, that's 135. So let's agree that 135 divided by 2 is 67.5. So first of all, recognizing that. So basically, I have negative 1 plus 2 cosine squared of 135 over 2. So we're doing that so I can recognize that, like, I'm going to be using one of my half-angle formulas. Okay. So my half-angle formulas say that if you have an angle divided by 2, you can take that angle that was divided by 2 and put it in your problem. So that's what we're going to be doing. So let me write that one down because I'll actually be using this one. So cosine of theta over 2, cosine of theta over 2 is plus or minus big square root 1 plus cosine over 2. All right, now this plus or minus isn't going to matter either because we're squaring it. Okay, so I have negative 1 plus 2 something squared. So cosine of this, I'm going to put 135 where my theta is. So that means it goes right here. So there's plus or minus big square root 1 plus cosine of 135, and then there's a 2. So all we did was I put the square outside, so then I had cosine of this half angle thing, this thing right here, had it squared. Alright, so I put this in there. My number was 135 over 2, so I put 135 right there. Okay, so my square goes away. So all I have left right here is 1 plus cosine of 135 over 2. And my job here is just to simplify this. All right, so my 2's cancel. And so I get negative 1 plus 1 plus cosine 135. The 1's cancel, so cosine of 135. 135 is right over here in the middle. So the cosine there is negative radical 2 over 2. And that is it. All right, I'll see you next time. Bye-bye.